Hi, this is Yvonne Fish. I'm going to go through a pre-calc problem in my Open Math. It's for exponential and log applications. The count in a bacteria culture was 200 after 20 minutes and 1,000 after 35 minutes. Assuming the count grows exponentially, what was the initial size of the culture? So the first thing to do is just set up your basic P of x equals a b to the x, and then plug in the points that you have, and keep in mind which is the x and the y. So the 20 minutes, that's my first x, so I have 20, and then it's 200 is the population. And for the other one, it's 35 and 1,000. So using those 2 points, I can set up a system of equations, and I can write them out and figure out what B is and what A is. So I'm going to need the base later, so I'm just going to go ahead and figure that out first. But so we have A, B to the 20, and then we have or 200 equals a b to the 20, and then for the other one 1,000 equals a b to the 35th. And there's a couple of different ways you could go ahead and do this. I'm going to actually just solve for a in this equation. A equals 200 over b to the 20th, and then I'm going to take that and substitute it in for a into the other equation. I'll write that in red, and then so I would get 200 b to the 35th over b to the 20th. So then my b's will reduce when I subtract my exponents, and I will get 200. So this is going to become 200 b to the 15th, and then divide both sides by 200, and that will become 5 equals b to the 15th, and then raise each side to the 1/15th, 1 over 15. And so b is equal to 5 to the 1/15th. You could calculate that out, but if you do, you need to make sure you go out at least about 6 places. So it comes to 1.113263. But I'm going to actually leave it just as this. Then I can go ahead and plug that 1/15th back in for A here. And I can actually right here 5 to the 1/15th. And so I'll write that over here. This is going to solve for A. So I would get 200, and then I would have 5 to the 1/15th raised to the 20th. And I'll go ahead and pop that into Desmos just by right here. So I would have 5, and then I would have my 1 over 15. I have to raise that up though. So I have to hit this A to the B key, and then I have to then hit my fraction key. And I would have 5 to the 1/15th there for my B, and we had that A equals 200 over 5 to the 1/15th raised to the 20th. So I'm actually going to just write that all in one thing. Let's see if I can get that going. 200, and then on the bottom I have the B, which is going to be my 5 to the 1/15th. And then I'm going to raise that to the 20th. See if that works. Yeah. So that's all raised up to the 20th because I hit the A to the B key. And I get 23.39214 in the direction, say, round to the nearest 100th if you want. So 23.39 would be what I have for A. So A equals 23.39. And that's my initial population. So it's my bacteria count. Then to get the doubling time, what I need to do is just go ahead and put in double. So 2 for my end population for the P of X. And then I'm going to put in 1 for my A, and then I put in my B, which is 5 to the 1/15th, and then I need to raise that to the T. So now I need to use logs. So I'm going to take the log of both sides. Well, and 2 divided by 1 is just 2 there. So I'm just going to write log. Then this T will come down. So I end up with log 2 equals T log 5 to the 1/15th. Is my B. Or you could put in 1.1132686, but make sure you write out enough places or you will get rounding error. Then go ahead and divide both sides by log 5 to the 1/15th. Then just go ahead and make that calculation in Desmos. I'm not going to type that in, but that should come out to be T equals 4.46, and that is your time. For the doubling, and that is going to be in minutes. Okay, then find the population after 80 minutes. So we're going to go ahead and make an equation in general for our P of T. We can now write, instead of AB to the T, we can actually fill in the missing pieces here. We don't know our end amount, but we know our initial from part A up here, A is 23.39. Then I have my B to the 1/15th. Oh, sorry, 5 to the 1/15th for my B. And then my time in this case is 80. So I'm going to just crunch the numbers there. So be careful when you're entering this in to follow your order of operations. So I will go ahead and show that one. So I'm just going to use parentheses and such. So I have 23.39 for A, and that works out fine if you don't write everything out for this one. But then I'm going to put in my 5 to the 1/15th. And then raise that to the 80. But what I can actually do is using my properties for exponents, I can just put in the 80 there. And I get 124,988.5544. And they round to the nearest, looks like 1,000, so 125,000. And the answer in my open math for that one. And that's bacteria for units. When will the population reach 11,000? So we have to plug in the same way, except we're going to be solving for T and using our logs, very similarly to what we did above here. So that one I would set it up as 11,000 as my population. Then I would have my A is 23.39. My B is the 5 to the 1/15th. And then my T is the unknown. Okay, so again, I could really write it as just T over 1/15. Make it a little easier. And then my first step is to divide by 23.39. And I'm just going to keep that as is so I avoid rounding. And then I'm going to take the log of both sides and use my log properties. So when I do this, I end up with, I'm just going to get rid of this here so I can see better. So now I can use my log properties, and this exponent, remember, comes down in front. So you just have to be a little careful here when you're writing this. So you have log 11,000 over 23.39 in parentheses equals, and that's going to come down T over 15 log 5. Don't forget to write the log. And then this is really like being multiplied there too. So again, the T over 15 is being multiplied by log 5, so that comes underneath. So that might be a little bit tricky, but just multiply by the reciprocal. So what I'm doing here is I'm going to divide both sides by log 5. But I'm multiplying by 15. So it's multiplying by the reciprocal. Okay, so to type this all in Desmos, you can do 15 and then parentheses, and then do log. Let your function do log, and then make sure you use either the fraction key or parentheses, and you're going to have 11,000. And then your 23.39 in the denominator. And then we still need to do parentheses. Make sure you go up from the denominator when you're putting your parentheses in there. And then we need to divide all of that by the log 5, and then and your answer is 57.34929, and I think in your thing you can round to 2 places, so we could say 57.35. And that is in minutes. Now, if this were a written homework, you would write out your sentences and things, but your in my open math, it's already set up for you, and you don't enter the units in, but just keep in mind what they are so that you're tracking with that. So I hope that helps. Have a great day.